Hello everyone, thank you for showing interest into this topic. I'll be talking about the process of identifying parameter constraints for complex web APIs, a case study which we executed at Adyen. Adyen is a payment service provider, and as a result, a lot of the things are payment related in this presentation. Imagine you want to make a request to this payments API. For making any request in an API, you look at the API reference, which describes all the possible parameters. There's quite a lot of them, so you go through them, you format your request on the right, and eventually you're like, all right, we have a request, let's submit it. And you get a erroneous status code back. It's like, something's wrong with the billing address. So you look at the billing address, whether you missed something, and you can't quite figure it out. So, as it turns out, when you make a request for the US or Canada, you need to provide the state or province as well. The problem here is that these constraints are not documented, and as a result, it could take you a lot of time to figure out what's actually wrong, especially for complex APIs, for which there can be hundreds of parameters which you might have to go through to figure out the problem. Another aspect is that these constraints might be unknown to those providing the documentation, since technical writers tend to be a different group than those writing the code. And as it turns out, 4 in 5 REST APIs actually contain interparameter constraints, based on a recent field study. So, as you can imagine, they're quite frequent. What else has literature done up until this point? As I mentioned, they try to understand what they're like in practice, how common are they, what different types do we see, what's their parity. Furthermore, they focus on establishing syntax to express these interparameter constraints. And furthermore, which is more related to what I will be talking about in this presentation, is developing techniques, automated techniques for identifying the constraints in simple APIs. Simple being around 5 parameters. Our goal is to be able to automatically identify these constraints for complex web APIs. Complex referring to the amount of parameters. Within this case study, there are roughly around 20 to 350 parameters. We'd also want to have them in a machine-readable format. What are the use cases of having these constraints? It would enhance the documentation for people consuming your API, which would consequently reduce staff loads and make people less frustrated in the end. Furthermore, it would enhance your contract testing, and if you do this kind of request validation at the start of your API flow, like your internal API flow, you'd be able to get rid of any malformed request before going through all the logic in your system, which would make it more efficient. Furthermore, you can use these constraints to gain insight into the complexity of your endpoints. If you know an endpoint contains a lot of these interparameter constraints and other dependencies, you might want to consider refactoring it or redesigning it. I distinguish between two types of constraints. There's interparameter constraints and there's single parameter constraints. So single parameter constraints, they apply on a single parameter. So things like restrictions on the length, maybe the format. And then there's interparameter constraints, which are constraints between 2 or more parameters. The approach. We have 2 distinct sub-approaches: documentation analysis and code analysis. Here we see an overview of the steps we use to arrive at a final set of constraints. First, we collect service information, which consists out of things like parameter names, their descriptions, their types, and the endpoint they belong to. For documentation analysis, we first look at all the documentation and try to find which parameters might possibly be related. So for example, here we see that bank account and card are referenced in the same sentence. So we guess they might be related in some way. We encode this in a co-occurrency matrix, and as an output we get sets of possibly related parameters. Then, in the second phase, we look at whether they're actually related or not. We do this by generating all combinations between these parameters and then making a request out of them. And based on whether the request was successful or not, we can fill this table, and using Boolean logic we can arrive at a final constraint. The code analysis, it works differently. It directly extracts the constraints from the source code. A bit of a side tour: how do we know that variables correspond with parameters? We know them because the variable names need to align in the deserialization process. This is a common practice. Using this dummy code here, you can see how it would work. If the request amount is greater than 999, something would go wrong, so we know that the amount must be less than or equal to 999. This is a single parameter constraint. For interparameter constraints, this works much the same. In practice, code is a bit more complicated, and in the paper we describe a lot of these intricacies that go into using static code analysis for parameter constraints in, well, enterprise APIs. The results. We had two questions: how effective are the approaches and what are the challenges? In order to answer these questions, we studied 3 distinct APIs with 10 different endpoints containing 53 interparameter constraints in total. In terms of complexity, they had between 350 and 10 parameters for each endpoint. The system we studied, it's Adyen, it's Java based, and about 14 years old. The code analysis and the documentation analysis, they performed quite differently. In terms of true positives, code analysis scored about 53% for the interparameter constraints, and documentation analysis scored about 20%, quite a bit lower. They do not necessarily find the same interparameter constraints, so combining the approaches, we get 66% of the 53 predefined interparameter constraints. For single parameter constraints, only code analysis was able to support this in our case, and we found that it was able to detect 78% of the single parameter constraints. The challenges for documentation analysis are that often there is no explicit information about constraints at all in the API reference. And sometimes it's implicit information. It is hard to leverage because current text analysis approaches are, well, not always able to analyze this. Another reason was partial information, which is explained in more detail in the paper. For static code analysis, it was mostly a matter of the approach being data flow insensitive and being able to design code analysis in such a way that it's still sound. For future directions, I suggest we should explore the effectivity of such automated approaches in different APIs still, and look into standardizing interparameter constraints for documentation. So, in conclusion, how effective? Combined 66% of the interparameter constraints. Code analysis appears to be more effective, but it contains more false positives. And in terms of challenges, for documentation analysis, mostly the lack of information about these constraints in the documentation to begin with. Furthermore, for code analysis, it's mostly a data flow analysis problem and engineering such a system in a sound way so that we still have reasonable runtime performance. Thank you for watching the presentation. If you have any questions, don't hesitate to email me. Thank you.
Good afternoon to everybody. My name is Giuseppe Scaniello. I'm from University of Basilicata in Italy. You are attending this session. The name of this session is API usage and refactoring, and this session is blended the session room. The first speaker is Henk. You have attended his video, his pre-recorded video. If you have any question, please write your question in the chat. We have a first question. Let me read the first question. Was there anything peculiar about the Adyen use case that you think would poorly generalize to your results?
Good question. The first thing which comes to mind is the use of their own framework. I don't know how much I can explain about their own framework, but it's similar to Spring, and they use it for internal APIs and their external APIs. And I think that part would be interesting if different companies could be reviewed for this reason. But besides, nothing immediately comes to mind.
Mm-hmm. So can you maybe elaborate more on the kind of documentation you need and the particular APIs you are able to handle in your approach? I think that Ivan was interested in this kind of aspect about the generalizability of your results.
Right, yeah, sorry, missed that part. Documentation, as stated in paper, we use a lot of the API reference, and for that we use like the Open API standard. So I think that's quite a standard thing among different other companies as well, different APIs as well. So that part would generalize well. And in terms of particular APIs, I think a lot of APIs nowadays, they're more pragmatic REST or REST, whereas Adyen, they still share a lot of RPC-like practices.
And if I can also complement the answer, Ivan, I think it's really interesting to see the other way around. So existing related work, they mostly study APIs that are open, let's say Twitter or Google, etc. And they usually use those small libraries on GitHub that is kind of a small layer that helps you to communicate with the API. And those projects, they are very simple to be parsed and understood. You know, it's just one if condition or a sequence of if conditions for each one of the constraints and etc. In our case, we are really parsing the complex source code of the web service, so it's just much harder to find in comparison to the related work. So I think that's a very good thing to think about if you're thinking of work on this area, to see the papers out there and our paper. I think that's the big difference.
Okay. The second question is from Pascal. I have missed in the session, but please, what tool were used to automatically identify the constraints from the code?
From the code, let me think. A lot of it, I used some tool, I think it was called Spoon, to parse Java classes into syntax trees, abstract syntax trees. And then based on those, I basically implemented my own tool around it. So basically not a lot of tools.
Okay.
And this tool, Pascal, is not available. We didn't make it open source, given that this was conducted inside of a company and it was not so easy for us to open the source code. Mm-hmm. But I hope the description in the paper is good enough. And if you have questions later about it, just let us know.
Okay. There are more questions here? No?
I think Ivan still has a question.
No, I think there are no. So I have a question. I forgot to mention that Henk is from Adyen, Amsterdam, but it was clear from the video that we did not see, unfortunately. But we have the chance to see this video offline. So I would like to ask some question, indeed a question about how the company and the developer of that company were involved in the experimental assessment. Because you mentioned in your paper more precise numbers about the overall quality of the tool, of your approach. So,
wait, if I get your question correctly, you're interested in how internal developers at the time helped with the evaluation of the results.
yeah.
Yes. Well, in order to assess the effectiveness for acquiring like a ground truth set, discussions with developers related to all the respective APIs. So there is one API which does like, okay, but let's maybe not go into detail, but different developers for different APIs, and I talked to them in order to make sure I could collect a good ground truth set. And using this ground truth set, I evaluated the effectiveness.
Okay. Thank you. We have 3 minutes left. There are some questions. Okay. I forgot to mention that this paper was from the software engineering practice track. So, Maurício, do you want to add something else? Or?
Yes, I was going to say that I think Ivan asked a question about our plans, and I gave my answer. So he asked what we plan to do with those constraints, and my answer was that I think at the beginning of the project, our goal was to improve the documentation. But Henk, given that you are from the company, what was our main goal when doing this?
Improving the documentation is definitely a large part of it. But also coming back to API design, now it's interesting to know if whether the initial design for the API is actually implemented as well. And this comes back to API first development. And alongside this is something, it's a bit of an umbrella term, but contract testing. It also comes back to API first design. And another use case, which is mostly a thought, is for API linting. Like, given you can extract the constraints for your endpoints, it also provides you with some insight as to how complex those endpoints are. But in the end, that didn't turn out to be way too interesting within Adyen.
Well, we have a couple of new questions from the audience. I think that we don't have enough time to answer both of them. We should check some. We can meet in a discussion room, so Henk can provide all the clarification, all the answer to your clarification question, and then. I hope that you can interact and maybe start some collaboration with the other guys that have attended this session. We have 40 seconds, so let me read the question. In case you will not able to answer properly to that question, you can interact with Ivan later. The question is wondering about maintainability. Wouldn't the dev now need to also maintain constraints in addition to regular docs?
Okay, with 12 seconds on the clock,
10 seconds.
I think we'll take it to the discussion room.
Yeah, okay. Thank you again, Henk. We will meet later in the discussion.